For the 4 lines shown, AB is parallel to DE. So the way we mark that, remember, is with this arrow. Now that doesn't mean anything about the lengths. I'm not marking anything congruent. I'm just saying parallel lines tell a lot more about the angles of how things meet, right? So so they gave us that these are parallel, and they also gave us that C is the midpoint of BD. So there's a lot that we can start marking knowing that information. If C is the midpoint of BD, then I know that BC is congruent to CD because C cuts this in half, and those have to be equal, right? So that's just definition of midpoint, or cutting things in half, right? And if these two are parallel, I know a lot about the angles. It means that this angle is going to be the same as this angle because they're alternate interior. And it also means that this angle is going to be the same as this angle because they're alternate interior, right? This is a parallel line cut by a transversal, so alternate interior angles. Parallel lines cut by a transversal, alternate interior angles. Lastly, we also know that this angle is going to be congruent to that angle because they're vertical angles. So there's just a whole lot about this picture we can mark up and already know about it. So they want us to prove that triangle ABC is congruent to triangle EDC. And that's pretty easy. We've got more than angle here. We've got all 3 angles. And we've got one side that's corresponding, one pair of corresponding sides that are congruent. So that means scale factor of 1. So if we're going to prove it, we're going to do an actual proof. Again, we're going to start with what's given. AB is parallel to DE, given, right? I'm going to say C is the midpoint of BD. That's given. So you start with your givens, and then you start saying what you know about them. I knew, because this was parallel to this, that angle A is congruent to angle E. I knew that because of alternate interior angles, right? And I also knew that angle B was congruent to angle D for the same reason, alternate interior angles. Now, I could go ahead and say that this ACB is congruent to DCE if I wanted to by vertical angles, but that's more than I actually need. I only need angle, and at this point I've got it in my proof, so I'm not going to waste my time with that. I also know that segment CD, is congruent with segment CB because C cuts BD in half. Okay, so I know those two have to be congruent, right? So now, do we have enough? So this is enough to say triangle ABC is congruent to triangle EDC by angle, and scale factor equal to 1. So we proved triangle ABC is congruent to triangle EDC. Now, using your work in part A, explain why you can also conclude that C is the midpoint of AE. So now we can further that, explain why. Now, if these are congruent triangles, then corresponding parts have to be congruent. So BC, if you look here, BC is congruent to DC. We said that, right? So that means that CE has to be congruent to CA. CE, right? These two congruent to CA, right? So I could further this. Let's say this is my proof for the two triangles being congruent, but if I wanted to add to it, I could say CA is congruent, segment CA is congruent to segment CE, right? And if those two are, and this is because corresponding parts of corresponding triangles are congruent. So I'm going to shorten that, but that's the real long answer. Corresponding parts of congruent triangles are congruent, right? So if these two are then congruent, then C is the midpoint of AE because C cuts AE into two equal parts. So that's the definition of a midpoint, right? So that's how you would prove. So this is where you stop for A. This is where you continue if you're trying to prove B.